Hi everyone, this is lesson 2-2, polynomial functions. Our learning target for today is to graph transformations of monomial functions. Before we begin graphing polynomials, we need to know what is a polynomial. A polynomial is a function that is the sum or difference of many monomials. A monomial is a function with a single term, because the word mono or prefix mono means one. The general form of a polynomial is y equals, or f of x equals, this equation here, a sub n and a sub n minus 1 and a2 and a1 are all the coefficients of your variables. A0 is considered your constant, a sub 0, and here a sub n is called your lead coefficient. N right here, the first exponent, is called the degree of your polynomial. The degree is equal to the highest power. So we'll say the power of n is the degree, which is also known as the highest power or exponent in your polynomial. In example 1, we're asked to graph f of x equals x minus 3 to the 5th power, and we're asked to graph this transformation. In chapter 1, we talked about transforming different functions. We talked about all the different parent functions, and then the transformations vertically and horizontally by stretching or compressing them, as well as translating them or sliding them from side to side or up and down. Now this function right here is f of x equals x minus 3 to the 5th. Its parent function is just y equals x to the 5th power. Now, if you realize that we can graph this by saying x minus 3 to the 5th, graph this function f of x equals x minus 3 to the 5th, and our parent function is x to the 5th. If you compare these two functions, you can see that we're subtracting 3 inside the grouping symbols. So anytime we add or subtract inside of a grouping symbol, we are translating or shifting horizontally. All horizontal transformations are opposite of the sign. So we're going to say we are shifting right 3 units. The difference between the parent function y equals x to the 5th and the function we're given here is that the function f of x is translated 3 units to the right. So if you graph this parent function x to the 5th on your graphing calculator, and you also graph f of x equals, in parentheses, x minus 3 to the power of 5, you will see that the functions are the same shape, but the second function here, f of x, is just translated 3 units to the right. I've gone ahead and graphed both the functions, the parent function y equals x to the 5th, which is in red, and I've graphed f of x in blue here, which is our translated function 3 units to the right. You can see that both graphs, the parent function y equals x to the 5th and f of x equals x minus 3 to the 5th, have the same shape, just the blue graph has been translated or shifted 3 units to the right. So each of the x coordinates, each point on the graph, right here, if I take a couple different points, you can see that each of these points have been shifted over 3 units to the right. Okay, so our translation here is 3 units to the right, and all you're asked to do is graph the function. You can use your table of values to graph your function and plot exact points. So go ahead and graph both the parent function and the transformed function on the same axes, like I have shown here. In example B, we're asked to graph the function f of x equals x to the 6 minus 1. The parent function of x to the 6 minus 1 is just the monomial x to the 6. And so what we're going to do is we are going to graph both functions, y equals x to the 6th and y equals x to the 6 minus 1. This minus 1 is on the outside of the grouping symbols, so I know that this minus 1 is going to shift the parent function down 1 unit. So essentially, y equals x to the 6th and f of x equals x to the 6 minus 1 are the same shape, just f of x is going to be shifted down 1 unit. So I'm going to go ahead and graph both these functions on the same window, and we can view and confirm that the translation is 1 unit down. So we have graphed x to the 6th, which is the parent function, and we've graphed x to the 6 minus 1, which is in purple. The parent function here is in green. So this is the parent function. Here, x to the 6 minus 1, which is the function we are given, which is transformed. We said it was translated down 1 unit. This minus 1 shifts the graph down 1 unit. You can see the minimum here on the parent function is now shifted down 1 unit to 0, negative 1. And we can confirm that in the table here, the parent function has a minimum at 0, 0, where our minimum for x to the 6 minus 1 is at 0, negative 1. Negative 1 is the lowest y value here, whereas 0 is the lowest y value in our table for the parent function. So all I'm asking you to do for this lesson is to be able to look at these different monomials, which the parent functions are always going to be monomials, one term, and then you're going to be asked to graph some sort of polynomial, in which case this x to the 6 minus 1 is considered a binomial because there's two terms, x to the 6 and minus 1. So what I'm asking you to do is graph both those functions on the same axes and go ahead and provide a table. I don't care how many points you use. I guess you're going to have to use at least 3 points for each function, and just provide a complete graph of both the parent function and the transform function. Okay, example 1, guided practice here. I'm going to check your understanding of what we've been talking about. Here we're asked to graph the function f of x equals 2 plus x cubed. I would like you to go ahead and graph this function and identify which graph, A, B, C, or D, matches that function. On top of that, think about what is the parent function of 2 plus x cubed, and what type of transformation is involved between the parent function and f of x equals 2 plus x cubed. So all I'm asking you to do right now is graph this function and match up your function, this function, with the correct graph, A, B, C, or D. And press submit.